In this video, we will take a look at SGDE, a runtime tool from the AI SPRINT project. The idea of SGDE comes from the concept of data islands. Today, edge devices produce and store huge volumes of data. However, moving this data across different devices is inefficient, both from a computation and communication perspective, and raises privacy issues. A possible solution is federated learning, or in short FL, which enables confidential training of AI models from data directly stored at the edge. In federated learning, the training task must be defined beforehand, and a single model may not satisfy each user due to data heterogeneity. So, our solution is to rely on synthetic data. Synthetic data resemble real data but do not compromise individuals' privacy, and therefore can be freely shared across the internet. SGDE is an alternative framework to federated learning, as the items exchanged are not model gradients or model weights, but fully trained generative models which can build synthetic datasets. SGDE is therefore designed for cross-silo federations where companies and institutions are the main actors. So, without AI SPRINT and without SGDE, AI models are trained with the iterative gradient exchange of federated learning, leading to expensive bandwidth usage. Also, federated learning frameworks suffer from poisoning attacks due to the principle of confidential data. Federated learning models also require ad hoc personalization efforts to cope with heterogeneity. Instead, when using SGDE, generative models are shared in just a single communication round. Also, non-confidential data access makes poisoning attacks easier to detect, with, for example, summary statistics on the available data. And finally, synthetic data can be reused for multiple offline tasks. So, SGDE is composed of two main parts, the server component, which provides a fast API endpoint based on pedantic objects, and its persistency is achieved using an SQLite database, and of course it runs inside Docker containers. The other part is a client component, which is a Python library based on TensorFlow that provides utilities for training and managing these generators, which are saved in ONNX format. Now we will take a look at a brief tutorial on how to use SGDE. This is a tutorial on how to use the secure generative data exchange tool from the AI SPRINT project. In this tutorial, we are taking a look at the Python notebook that is provided within the SGDE repository on GitLab, and here we are impersonating a client that is interested in sharing synthetic handwritten digits images, and we are using, of course, the classic MNIST dataset to showcase our tutorial. So first, let's make some standard imports of libraries such as TensorFlow and NumPy. And let's import the MNIST dataset. Let's now apply some standard preprocessing, such as data normalization and training and test split. And finally, let's train a new data generator. For time reasons, we are not training a new generator on the fly, but we have an already trained generator. As you can see, we can import a single function from the SGDE client module, and with this function we are producing a new data generator on the MNIST dataset. We can see that the training starts by producing a data classifier on real data, and this classifier is then used to help the data generator in order to produce better images. As we can see, as the epochs increase, the quality of the handwritten generated images becomes better and better. Here we trained for just 30 epochs, but of course, by increasing the processing time, we can obtain a much better data generator. At this point, we can load the metadata that has been produced during the training, and we can generate some synthetic samples. In this case, we are importing the generate samples ONNX from the SGDE client library, and we are producing 100 new samples, and then we are plotting 10 of them. And here we are. Now, an interesting parameter is a filter model, which can be, of course, true or false. And if true, the data classifier takes part in the generator process in order to produce better images. And here is an example of images generated this way. Then we can register to the SGDE API by providing a username, an email, a password, and here we are. Then we can log in. We can check if we are successfully logged in, and we can upload the previously trained generator. And here we go. We can check whether our generator has been effectively uploaded to the SGDE server, and we can see it here. And we can download any generator on the server. In this case, there's only the generator called myGun. And so we are downloading this. And we can generate samples from the newly downloaded generator. In the next slide, we are seeing the performance of federated learning and SGDE compared on a set of simple classification tasks. As we can see, the performance of SGDE is comparable to the one of federated learning. Therefore, training on the synthetic data coming from SGDE is an effective solution with respect to training a model using federated learning. In conclusion, we can say that SGDE is an alternative framework to federated learning for cross-silo federations. Its goal is to provide each client with a representative synthetic dataset that can be used for offline machine learning tasks. Synthetic datasets are built using data generators, which produce synthetic samples that retain the patterns of original data without leaking sensitive information. Thank you all for the attention.